Hey there, tech enthusiasts. Welcome back to my channel, your hub for all things coding and software development. Today, we're diving into asynchronous programming. We'll be using WinForms to make our examples visually engaging and fun. So, grab your favorite beverage, get comfy, and let's get started. Hi there, ever found yourself tangled in the web of asynchronous programming concepts? It can be a bit overwhelming with all the buzzwords and complicated examples, right? Well, not anymore. Today, I'm going to break it down for you and show you how to harness the power of async programming effortlessly in C# using WinForms. Ready to make your apps faster and more responsive? Let's dive in. Before we get our hands dirty with code, let's quickly grasp what synchronous and asynchronous programming mean. Imagine you're at a fast food restaurant. In a synchronous setup, you place your order and wait at the counter until it's ready. Task A, ordering, must be completed before Task B, receiving your food, begins. It's a step-by-step process. Now, picture an asynchronous setup. You place your order and get a buzzer. While you wait for your food, you can grab a drink, find a seat, or even start chatting with a friend. Tasks can run concurrently, making the process more efficient. This is what asynchronous programming does for your applications, makes them more efficient and responsive. Two major benefits of asynchronous programming are: responsive user interface, your app remains interactive even while performing long-running tasks. No more frozen screens. Parallel task execution, independent tasks can run simultaneously, speeding up the overall process. Alright, let's switch to Visual Studio.
Can I do the next video, boss?
Good question. Let's wait for some comments or feedback from our follower. Maybe you can explain some topics in the following videos from me.
Okay, let us wait for some feedback. Thank you.
No problem. But now I have to keep going. I'm currently in the middle of a video. I've set up a simple WinForms application to demonstrate this. We have two buttons, one for synchronous execution and one for asynchronous execution. We also have a text box to display results. Let's start with the synchronous method. Here's the code behind the synchronous button click event. You see there the stopwatch for our result and some pre-created methods. Get websites returns a list from website addresses that we use for our test. In the method download website, we use a web client to get data from the different websites. To be more clear, we use the class website data to create the data and use it also as a return value. Last, we use the report result method to put the data into our text box. When we run this code, it will download each website one after the other. Let's see it in action. Click the Execute Synchronously button. Notice how the entire application freezes until all websites are downloaded and the results are displayed. Not the best user experience, right? Now, let's make it asynchronous. Here's the code for the asynchronous button click event. In this version, we use task run to download websites concurrently and await task when all to wait for all tasks to complete. Let's see how this performs. Click the Execute Asynchronously button. Notice how the application remains responsive. You can still interact with the UI while the websites are being downloaded. And once all tasks are completed, the results are displayed along with the total execution time. There you have it. By simply using async and await, we've made our application much more user-friendly and efficient. No more frozen screens, and tasks get done faster. Asynchronous programming can seem daunting at first, but with practical examples like this, it becomes much easier to understand and implement. If you found this video helpful, give it a thumbs up and subscribe to my channel for more programming tutorials. Drop a comment below if you have any questions or if there's a specific topic you'd like me to cover next. Thanks for watching, and happy coding!